Q5680. A helicopter is loaded in such a manner that the CG is located aft of the aft allowable CG limit. Which is true about this situation? A. In case of an autorotation, sufficient aft cyclic control may not be available to flare properly. B. This condition would become more hazardous as fuel is consumed if the main fuel tank is located aft of the rotor mast. C. If the helicopter should pitch up due to gusty winds during high-speed flight, there may not be sufficient forward cyclic control available to lower the nose. The correct answer is C. If the flight is continued under these circumstances, the pilot might not be able to maintain a nose-low attitude or fly in the top permitted airspeed range. This is because there is not enough forward cyclic displacement. If gusty or choppy air drives the helicopter to a faster velocity than forward cyclic control would allow, this specific situation might become highly deadly. Full forward cyclic stick may not be enough to maintain the nose down or to lower it after it has started to rise. 5681. A helicopter is loaded in such a manner that the CG is located forward of the allowable CG limit. Which is true about this situation? A. This condition would become less hazardous as fuel is consumed if the fuel tank is located aft of the rotor mast. B. In case of engine failure and the resulting autorotation, you may not have enough cyclic control to flare properly for the landing. C. Should the aircraft pitch up during cruise flight due to gusty winds, there may not be enough forward cyclic control available to lower the nose. The correct answer is B. Flight under these circumstances shouldn't be continued since the risk of running out of rearward cyclic control will rise quickly as fuel is used up and the pilot might not be able to slow the helicopter down enough to stop it. Additionally, there could not be enough cyclic control available in the event of engine failure and the ensuing autorotation to adequately flare for the landing. 5287. In regard to the location of the glider's CG and its effect on glider spin characteristics, which is true? If the CG is too far? A. Aft, a flat spin may develop. B. Forward, spin entry will be impossible. C. Aft, spins will degenerate into CG high-speed spirals. The correct answer is A. A glider with an aft CG is more likely to enter a flat spin. A flat spin is a type of spin in which the aircraft's nose is pointed down at a relatively shallow angle, and the aircraft rotates around a vertical axis. Flat spins are more difficult to recover from than regular spins, and they can lead to a high-speed spiral if the aircraft is not recovered quickly. A glider with a forward CG is less likely to enter a spin. This is because the forward CG position creates a nose-up moment which makes it more difficult for the aircraft to stall and enter a spin. 5288. The CG of most gliders is located A. Ahead of the aerodynamic center of the wing to increase lateral stability. B. Ahead of the aerodynamic center of the wing to increase longitudinal stability. C. Behind the aerodynamic center of the wing to increase longitudinal stability. The correct answer is B. The CG of most gliders is located ahead of the aerodynamic center of the wing to increase longitudinal stability. Longitudinal stability is the ability of an aircraft to return to its original flight attitude after being disturbed. A forward CG position creates a nose-up moment, which helps to keep the aircraft flying straight and level. A rearward CG position would create a nose-down moment, which would make the aircraft more likely to pitch up and enter a spin. This is why the CG of most gliders is located ahead of the aerodynamic center of the wing. 5289. Loading a glider so that the CG exceeds the aft limits results in A. Excessive load factor in turns. B. Excessive upward force on the tail and causes the nose to pitch down. C. Loss of longitudinal stability and causes the nose to pitch up at slow speeds. The correct answer is C. Loading a glider so that the CG exceeds the aft limits results in loss of longitudinal stability and causes the nose to pitch up at slow speeds. This is because the rearward CG position creates a nose-down moment, which makes the aircraft more likely to pitch up and enter a spin.